Hey, algebra students. I had someone reach out with some questions over Friday's lesson. So I thought maybe several of you had questions over it. So I thought I'd put together this little video for you and hopefully it will help you. So let me pull that up for you. All right, so when I think about adding radicals, I kind of think of it as adding fractions. So if I asked you, let's add 1/3 plus 4/3, am I allowed to add those the way it's written? Yes, because I have common denominators. So I would add my numerators, but I would not add my denominators. My denominator would stay a 3. If I asked you to add 1/2 plus, I don't know, 4/7, am I allowed to add those? No, because they don't have common denominators. I would have to find common denominators first. Well, that's kind of the way I think of radicals. So if you look at my first example, if what's under the radical matches exactly, then you can go ahead and add those coefficients that are sitting in the front. You don't add the 3's together that's under the radical. You just add your 5 and 2 and you get 7 square roots of 3. Okay, however, if they don't match, so my second example, if the radicals don't match, you cannot add them. So 2 square roots of 3 plus the square root of 5 cannot be simplified because 3 and 5 do not match. Okay, so that is the final answer. You can't do anything with that. However, just like with fractions with unlike denominators, you can multiply radicals that don't match. For example, 5 times 2 square roots of 3, there's no radical next to my 5, so I don't have anything to multiply my square roots of 3 by, but I can multiply 5 and 2 together, and I get 10 square roots of 3. If I had 2 square roots of 2 times 3 square roots of 3, once again, I would multiply 2 and 3 together. I would also multiply what's under the radical together, 2 times 3, and I would get 2 times 3 is 6 square roots of 6. So once again, when you're adding those radicals, what's under the radicals stays as part of your answer. You don't add them, but when you're multiplying, you multiply everything. You multiply the outside numbers and the inside numbers. And there's another example. Square root 2 times square root 3 is square root 6. All right, so just to remind you about your perfect squares, since 6 squared is 36, the opposite of that would be the square root of 36 is equal to 6. So do you guys remember your first 13 or 14 perfect squares? It will help you if you do remember those or you recognize them. So 1 times 1 is 1, 2 times 2 is 4, 9, 16, 25, 36, 49, 64, 91, 100, 121, 144, 169, 196. Next one would be 225. So if you can recognize those perfect squares, it'll help you when you try to do problems like the next set of numbers where you're trying to simplify non-perfect squares. So hopefully you guys agree with me that 50 is not in this list up here. So that means 50 is not a perfect square. However, 50 does have a factor that is a perfect square. So look at these numbers up here. What's the biggest number on this list? That's a factor of 50. Well, 25, right? So 4 is a factor of 50. No, it's not. No, it's not. I guess I was thinking of 100. Anyway, so can we think of 50 as 25 times 2? And we could actually break those apart. Square root of 25 times the square root of 2. Well, we know that the square root of 25 is a perfect square, right? What is the square root of 25? Square root of 25 is 5. Square root of 2 is not a perfect square. It's a prime number. And we have just simplified this non-perfect square. Square root of 50 is 5 square roots of 2. To check my answer, I could square the outside number. 5 squared is 25, and you multiply the outside number squared times what's left in the radical. So does 25 times 2 equal 50? Yes. All right, let's look at 32. So look at these numbers up here. What is the biggest number up here that's a factor of 32? Well, I know that 4 is a factor of 32, but that's not the biggest number. The biggest number up here is 16, right? So I could think of this as a square root of 16 times the square root of 2. Well, square root of 16 is a whole number. It's a rational number. Square root of 16 is 4. Square roots of 2, I know that 2 is a prime number. It has no factors that could possibly be a perfect square. So I am done with that. Now let's say for a second, let me erase that. Let's say I didn't pick the biggest perfect square. Let's say I forgot that 16 was a factor of 32 and I picked 4. All right, so I would think of this as 4 times 8. Well, then I would go, well, the square root of 4 is 2, so my final answer is 2 square roots of 8. But that's not right. It's not simplified because 8 actually has a factor that is also a perfect square. 4 is a perfect square. So then I would say, okay, well, square root of 4 times the square root of 2. Square root of 4 is 2. So square root of 4 is 2. And I would end up getting 2 times 2 is 4 square roots of 2. All right, so you want to make sure if you have a number left under that radical, you want to make sure that number does not have a factor that is a perfect square. Okay, and I'll talk about that a little bit on the next slide as well. All right, what about 90? Well, I know 25 won't go into 90. I know 36 won't, 49 won't. So let's go this way. What about 9? So 9, couldn't I multiply 9 times 10? 9 times 10. My pen does not like 9s. I don't know why, but it doesn't. 9 times 10. All right, well, isn't 9 a perfect square? The square root of 9 is 3 square roots of 10. So let's think about 10. Does 10 have any factors that are perfect squares? No, besides 1 and 10, the only other factors is 2 and 5. These are not perfect squares, so I'm safe there. And to check my answer, I could square 3. 3 squared is 9, and 9 times 10 is 90. All right, let's look at 72. 72. Now, another way we could check to see is not really we could just not worry about perfect squares and just think of all the factors of 72. Let's just break 72 down. Well, 72 is even, so I know that I could divide 72 by, what, 36? Actually, I don't want to start there because 36 is the biggest perfect square. Let's start with 8 and 9. 8 and 9. All right, neither of those are prime numbers, so I'm going to keep going. What are the factors of 8? 8 are 2 and 4. 2 is a prime number. 4 is 2 times 2. All right, I've broken 8 all the way down. What about 9? 9 has 2 factors besides 1 in itself, and that's 3 and 3. All right, so basically 72 is all the prime numbers, 2 times 2 times 2 times 3 times 3, all right? So if I multiply all those numbers together, I'm gonna get 72. Now, when you go into a shoe store and they want you to be able to see the shoes, are they gonna put 2 shoes on the top of every box so you can see both of them? No, they're gonna show you 1 shoe. But when you go to the cash register, you know you're not buying 1 shoe. Inside the box are 2 shoes. So if you see 1 shoe displayed, it represents 2 shoes inside the box. Well, that's kind of like square roots. For every pair of 2s, I get to pull out 1. 1 on the outside represents 2 on the inside. There's a pair of 2s. I'm going to pull 1 out. Well, I also see a pair of threes. I get to pull out one 3 that represents 2 3s. So I'm going to multiply 2 times 3, and then what's left under the radical? A 2. Now I'm going to simplify 2 times 3. I get 6 square roots of 2. And I've just simplified square root of 72. All right, now had I used 36 earlier, like I almost did, 36 is the biggest factor of 32. That is a perfect square. So 72 is 36 times 2. 36, of course, is a perfect square. Square root of 36 is 6. And square root of 2 cannot be simplified. And so that's my answer. I got the same answer, a little bit less work over here using my biggest perfect square, but sometimes we miss the biggest perfect square. So using prime factorization is a way to guarantee that you're going to get the final answer. All right, now when the numbers are so large, I would recommend that you do use prime factorization. All right, so let's start with, we'll just cut it in half. We'll do half of 1080 would be what? 540. 540 is even, so we'll half it again. So half of 540 is 270. Half of 270 is 1. I guess I could do this in my head, but my brain isn't working. All right, so let me circle all my prime numbers. All right, now 135 is not even, but it does end with a 5. So 135 divided by 5 is 27. And then my factors of 27 would be 3 and 9. 3 is prime, and then 9 is 3 and 3. All right, so 1080 is 1, 2, 3, 3, 1, 2, 3 twos, 3 threes, 1, 2, 3, and a 5. All right, so remember what we're going to do? We're going to pull out 1 for each pair. So there's a pair of 2s. There's a pair of 3s. And those are our only pairs. So our only pairs. So what's left on the inside? 2, 3, and 5. So 2 times 3 is 6. And on the inside, we have 2 times 3, which is 6. And 6 times 5 is 30. All right, so that tells me that I could have used 36. 36 is the biggest perfect square that's a factor of 180. Now, you might think, well, 30 is too big. It's got lots of factors. Well, it does have lots of factors, but none of them contain factors that are perfect squares. Did I just lie to you? I did. No, I didn't. Oh, duh, that's a 15. Okay, just kidding. So 2 times 3 times 5, none of those are perfect squares, and so this is actually simplified. So how do we check our answer? We square 6, which is 36, and does 36 times 30 equal 1080? Yes, it does. So that is the answer. All right, let's do 486. We'll do our prime factorization because it's a large number. So let's half it. So half of 486 is 243. In my head, I'm adding those numbers to see if that number is divisible by 3. So 7, 8, 9. So since those numbers add up to 9, that actually tells me this number is divisible by 9. So 243 divided by 9 is 27. So we have 3 times 3. This is 3 times 9, and this is 3 times 3. So we have a 2, 3, 3, 3, 3, and 3. So what do we got here? We have a 2, and then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh no, I have a phone call. Hold on. Hello? I am. I'll call you. Who is this? Okay, bye. All right, so I have a pair of 3s there and a pair of 3s here. So I get to pull out 2 3s. And then what's left on the inside? 2 times 3. Well, 3 times 3 is 9. Square roots of 6. Which means if I square 9, that means 81 was the biggest perfect square that was a factor. So does 81 times 6 equal 486? Yes, it does. So that's how we simplify non-perfect squares. So how does that help me with addition problems like the one here on the screen? Well, if I can make those radicals match, that means I can add some numbers together. All right, so the first thing we're going to do is think of 32, and I think we already did 32, didn't we? We did 16 times 2. Well, 16 is a perfect square. The square root of 16 is 4. So this would be 4 square roots of 2. So 32 is 4 square roots of 2. All right, 8, wouldn't that be square root of 4 times square root of 2? Once again, square root of 4 is a perfect square, so square root of 4 is 2. So this is going to be 2 square roots of 2. And then this can't be simplified, so minus square root of 2. So since the radicals match now, we can add those coefficients. So we have 4 plus 2 is 6 minus 1. Even though I don't see a 1, it's definitely a 1, right? 4 plus 2 is 6 minus 1 is 5 square roots of 2. And that's my answer. All right, now I'm not adding those what's under the radical, but when I multiply, I have to multiply them. Okay, so I'm going to multiply 2 times 5 on the outside times on the inside 3 times 3. So 2 times 5 is 10, square roots of 3 times 3 is 9. But since, of course, 3 times 3 is 9, that means 9 is a perfect square. So the square root of 9 is 3. So I'm going to multiply 10 times 3, and my final answer is 30. 30. Okay. Oh, there's another one. All right, let's see what we can have match. So let's just look at the 8. So 8 is 4 times 2. Well, the square root of 4 is 2. So we're going to bring down this 2. So 2 times square root of 4 is 2 square roots of 2. So that would be 4 square roots of 2. That's what this one is, 4 square roots of 2. Now, this cannot be simplified. Minus 4 square roots of 2. So what do you think 4 square roots of 2 minus 4 square roots of 2 is? 0. They cancel each other out. So what do we have left? Plus 2 square roots of 16. Well, 16 is a perfect square. 16 is 4 times 4. So 2 times 4. So my final answer is 8. 0 plus 8 is 8. All right, now we're going to multiply everything. We're going to multiply 3 times 4, and we're going to multiply square root of 6 times square root of 3. So 3 times 4 is 12. 18. 18 is square root of 9 times the square root of 2. Well, square root of 9 is 3. So 12 times 3 is 36 square roots of 2. That is the final answer. And then on this one, we're using the distributive property. Okay, so square root of 5 times 4 is 4 square roots of 5. Square root of 5 times the negative square root of 5, or minus square root of 5 times the square root of 5 is square root 25. So what is the square root of 25? It's 5. So 4 square roots of 5 minus 5 is my answer. And I can't add those because there's no radical over here and I have nothing to combine anything with. So that is the final answer. All right, here's a long one. All right, let's see what we can do with this. So the first one can't be simplified. Square root of 3, can't do anything with that. 6, the only factors of 6 besides 1 in itself is 2 and 3, which are not perfect squares. What can we do with 48? Well, 48, let's do a prime factorization tree. 48 would be what, 6 and 8. 6 is 2 and 3. 8 is 2 and 4. These are prime, 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 and prime. So square root of 48 is 1, 2, 3, 4 twos, 1, 2, 3, 4 twos, and a 3. So if you multiply all those together, make sure you get 48. So I have 2 pairs of 2, 2 pairs of 2. 2 times 2, square roots of 3. So 2 times 2 is 4 square roots of 3. So do I check it? Yes. I square 4. 4 squared is 16, and does 16 times 3 equal 48? Yes. So this is 4 square roots of 3. And then we have square root of 54 would be what? 9 times, let's see, 9 times 6. Sorry, my brain went dead. So 9 is 3 times 3. 6 is 2 times 3. I have 3 2s. No, I have 3 3s and a 2. 1, 2, 3, 2. So I get to pull out 1 3, and what's under the radical? 6. So I have 7 square roots of 3 minus 4 square roots of 6 plus 4 square roots of 3 minus 3 square roots of 6. Now what can I add together? I could add my square roots of 3. So 7 plus 4 is 11 square roots of 3. I can combine my negative 4 square roots of 6 and negative 3 square roots of 6, which is negative 7 square roots of 6, and I'm done. I can't go any further. All right, I think that's it. Yes. So I hope that helped you guys. So if you need any more assistance, reach out to me and I will see what else I can do. So I'll see you guys later.